Hello students, in the previous lecture we discussed coplanar forces. Now today I want to discuss the first chapter from dynamics, that is rectilinear motion. Motion. In general, a particle is said to have motion when the particle changes its position with respect to its surroundings. Different types of motions are, as shown, motion of translation, motion of rotation, and general plane motion. In case of translation, actual displacement of the body takes place from one position to another position. In case of rotational motion, the particles of the rigid body move along parallel circles, whereas general plane motion is the combination of translation and rotation. For an example, if we consider a case of bicycle, suppose a bicycle moves from one position to another position along a straight line. Then, if we consider the different parts of the bicycle, say for an example, the seat of the bicycle. When the bicycle moves from one position to another position along a straight line, its seat performs a rectilinear motion. It moves from one position to another position. Whereas, if we consider the wheel of the bicycle, then every particle, every point on the wheel performs the motion of translation as well as motion of rotation. So we say that the wheel of the bicycle is in general plane motion, whereas the seat of the bicycle is in translation motion. Now here let us discuss the translation motion, different types of translation motions. Translation motion is further subclassified into two types: rectilinear motion and curvilinear motion. Now, as we discussed, rectilinear motion is the motion of the particle along a straight line. Curvilinear motion is going to be the motion of the particle along a curve. Now, curvilinear motion is further divided as shown: circular motion, parabolic motion, and third one is motion along other curves. It may be elliptical motion, etc. So circular motion is the motion of a particle along the circumference of a circle. Parabolic motion is also termed as a projectile motion. So this is how the translation motion is classified. Now we are going to discuss the rectilinear motion in detail now. Now, when a particle performs motion along a straight line, it is said to have rectilinear motion. Now, when a particle performs motion along a straight line, that is rectilinear motion, it can be of following three types. First, motion with constant velocity. Second, motion with uniform acceleration. And third, motion with variable acceleration. Now, when the motion of a particle is happening with constant velocity, what you should remember is that for such motion, velocity v is constant. As v is constant, it means the acceleration is zero, and as there is no acceleration, force acting on the particle is also zero. So that is the motion with constant velocity. When motion is under uniform or constant acceleration, for such motion, velocity is not constant. The velocity is continuously changing, but the rate of change of velocity is constant, and this rate of change of velocity means the acceleration, which means the acceleration is constant, and as such the force is also constant. Now the problems of this kind, that is motion under uniform acceleration, can be solved by using the three equations of kinematics. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as, in which u is the initial velocity, v is the final velocity, a is the acceleration, t is the time, and s is the displacement. Now motion under gravity can be considered as a special case of motion under constant acceleration, in which the constant acceleration is called as gravitational acceleration, and its value is given as 9.81 meters per second square. The third type of rectilinear motion is the rectilinear motion, under variable acceleration. Now in such case, velocity is not constant, it is variable. Acceleration is also not constant, it is variable. And as such, force is also not constant, it is also variable. The problems of such type can be solved either by using the method of differentiation or method of integration. Now we can see that in this type of motion, the displacement is the function of time, the velocity is also the function of time, and the acceleration is also a function of time. So if x and t, or if the displacement and time relation is given, you will have to differentiate it to get the velocity, and the further differentiation will give you the acceleration. Whereas if the acceleration and time, or if this relation is given between acceleration and time, you will have to integrate it to get the velocity, and the further integration of this velocity expression can give you the displacement. Now, rectilinear motion can also be analyzed by using graphical approach, and for which we can plot three different types of graphs, which are respectively called as xt graph, that is displacement time graph, vt graph, that is velocity time graph, and at graph, that is acceleration time graph. Now whenever we plot any graph, our interest is always in two terms. First, what is the slope of that graph? Second, what is the area under that graph? Let us consider these three graphs separately. When we consider displacement time graph, the slope of xt diagram gives us velocity, whereas area under xt diagram has no significance. So when xt diagram is given, our interest will only be in slope of xt diagram, which is the velocity. When vt diagram is given, or when vt diagram is considered, the slope of vt diagram gives us the acceleration, whereas area under vt diagram gives the change in position, that is displacement, for the given time interval. At diagram, the slope of at diagram gives us the term which is jerk, which is nothing but the rate of change of acceleration, and the area under at diagram gives us the change in velocity. So you will have to remember these terms. Again, it is easy to predict the nature of any graph if we know the nature of any one of these three graphs. If xt diagram is cubic, then vt diagram is parabolic, and at diagram will be a straight line, which simply means that the degree of xt diagram is higher by single degree than vt diagram, and degree of vt diagram is higher by single degree than at diagram. For an example, if I say that vt diagram is parabolic, if vt diagram is parabolic, xt diagram will be a degree higher, that is it will be cubic, and at diagram will be a degree lesser, and it will be an inclined line, that is a straight line. So xt diagram cubic, vt diagram parabolic, then at diagram will be a straight line. If xt diagram itself is a parabola, then vt diagram will be an inclined line, and at diagram will be a horizontal line, will be a line parallel to x-axis. If xt diagram is an inclined line, vt diagram will be a horizontal line, that is a line parallel to x-axis, and at diagram will be coinciding with the x-axis, means there is no acceleration. So this is how the graphical representation of the rectilinear motion can be done. That's all about the rectilinear motion. Now in the next video I'm going to discuss different problems related to these two chapters, that is coplanar forces and rectilinear motion. So don't miss to see that video also. Okay, thanks.